The goal of this video is to give some introduction to PA8. I will not go into all the details. I highly recommend you actually go through the PDF document. Everything is very well laid out. But I'll just briefly touch on what this assignment is about, and then I'll just go through the first few parts. So in this assignment, you have basically you're given poses for aliens and human beings, and you will learn more basically from this data that's given to you. You will learn some parameters, and then eventually in the latter part of the assignments you will also learn the graph structure. You can read all the details. I'm sure if you go through this PDF, you will understand the notations and everything. But really, the things of interest here are these two models, these two graph structures. The one on the left is the naive Bayes model, where if given the class, that is, if given that it is human or alien, it assumes that the body parts are independent, whereas the more realistic graph structure, because all the joints are related, is to have parents, for example, like this part here, O4, its parent is O3, and so on. So the one on the right side is a much more realistic structure. And then you will actually, as you do different parts of the assignments, by the time you come to classify data, which is obvious, the accuracy for this second model would be way better than the naive Bayes model. So in the very first part, you're actually asked to finish this function, fit Gaussian parameter. So basically you're given an example, that's your input, and you have to find out the mu and the sigma. Now, if you, the reason really this is fairly straightforward. All the formulas are given right here for you. Now there's one thing I do want to draw your attention is this, that is, you need to set the option flag to 1 if you use var or std in the MATLAB and Octave, and same thing with the mean function. Okay, so that's pretty much straightforward. You're basically calculating the mean and sigma here. Okay, next thing, the next part. Okay, this is slightly more interesting. This is fit linear Gaussian parameters. So whereas in the naive Bayes model, you could just use this straightforward model here. You can parameterize them with this straightforward Gaussian, because each body part only has class level as its parent. It does not have more than one parent in the naive Bayes model. So this is again a straightforward implementation. However, when we talk about the fit, the conditional linear Gaussian, which is this guy here, fit linear Gaussian parameters, what we are trying to do here is, the x, okay, given the parents, if the parents are you, basically, how to linearize this Gaussian, how to parameterize that in a linear fashion. So That's what those parameters beta 1, beta 2, beta n, and so on. Now again, I'm not going to go into the derivation of all of this. If you're interested, actually, you can look at page number 728 of the book, Probabilistic Graphical Models. It actually tells you how to derive all this. Again, I'm not going to go into the details of this. One thing, however, I do want to say something about this here, which is please note that this u bracket 1 bracket begin 1 bracket close, that is just a subscript, so don't confuse that with some MATLAB, some matrix operation. Okay, so that u of 1 right there, that's not some matrix, that's just a u subscript 1, and u of 2, that is u subscript 2. So that's all really I wanted to say. The rest is again here, you probably have to do some magic for loops or whatever you want to do, but again, all the instructions, everything is right here for you. So if you follow this, that shouldn't be hard, I think. Okay, now before I close this video, so the next thing after you implement this, I believe, is log likelihood. Where is that? Yeah, compute log likelihood. So I'm actually going to make a separate video about this, but this compute log likelihood, because you will run into this in this assignment and also in the next assignment, I want to make sure that we understand what is the purpose of this whole log likelihood function. So if you look at, for example, this slide, I believe, so basically likelihood of parameters given data. So that's really what log likelihood is, and I actually want to read this, and I want to make sure this is well understood. So the log likelihood of the model or the data set measures how the model fits the observed data. So this measure allows us to compare different model choices quantitatively. So that's the whole point of this function, why this whole compute log likelihood. You're trying to do this so that you can properly evaluate different models. For example, in this case, naive Bayes model versus more realistic model where the joints have parents. Okay, so I really don't want you to lose track of the whole point of log likelihood and what this function is about. But I'll talk in more detail in the next video. So that's it for now. Good luck.